Good morning, Year 5. I hope you're all well and ready for another science lesson. This is week 2 of our unit on properties and change of materials, and we're going to be conducting another experiment today, which I hope you'll all be able to join in on and post some wonderful pictures and videos on Seesaw later on. Right, so let's get started straight away. So our date and our walt is here. So it's which solids can dissolve in water, and today is Monday the 18th of January 2021. So in my book I've written the date and walt here, and I've also made space for my do now. So if you'd like, pause the video here, write your date and walt just to get yourself into the right frame of mind, and to build the good habit of writing the date and walt. Okay, so hopefully you have that done, and we can move on with our do now. So here is our do now for this week, our knowledge quiz based on the current unit, the last unit, and what you did last year. So there's 5 questions to do. Once again, pause the video here, and I will reveal the answers very shortly once it's completed. Okay, well done. Hopefully you're well on your way to getting 5 out of 5 and you can remember as much as possible from last week. So, the answers. Have a blue pen ready or any colour pen ready to mark your work, and we will get cracking. So the first one, which state of matter, based on last week, has no fixed shape or volume? And the answer to that one was gas. So you can mark your work, either fix it or else give yourself a tick. The second one, what is the change of state from liquid to gas known as? So I have a liquid and it changes to a gas. What is that known as? It is known as evaporation or evaporating. So give yourself a tick for that one. Number 3, what is the change of state from gas to liquid known as? So if I have a gas and it changes to liquid, what happens? It's condensation or condensing happens. So give yourself a tick for that one. Okay, that was our current unit. That's what we're doing based on last week. Let's see who we got on with last unit. So in science last unit before Christmas, we were doing resistance or friction and forces. And our question here is, air resistance is a type of which force? And it was friction force. So give yourself a tick for that. And based on what you did last year, what is the breakdown of complex food that can be used by the body known as? And that is digestion. That's when you break down the food you've eaten so your body can use it for energy. So pause the video here if you need another couple of seconds to tick or fix your work. Otherwise, we're going to move on. Right, off we go. So a quick recap on last week's learning. So last week, we looked at the states of matter. There was solid, liquid, and gas. They were the 3 states of matter we covered. Now, what I want you to do is, I want you to pause the video here again. We're doing lots of pausing so far and lots of thinking. And I want you to see if you can identify the properties of each state of matter. Can you remember the properties that a solid has, the properties that a liquid has, and a property that gas has? So pause the video here and think about those from last week. Maybe refer to your book from last week of the notes you made and the lovely diagrams you drew. And when you're ready, unpause the video and see if you were correct. So solids. We know that solids keep their shape. They have a fixed volume. There's a fixed amount of it. And they do not change shape to fill a container. So if you had a container, like I have a container here. If I had this container and I tried to put loads of ice in it, ice would not change the shape to fit into it. So ice is an example of a solid. Solids keep their shape, they have a fixed amount or volume, and they do not change their shape to try and fill a container. Next we had liquids. Properties of liquids, they also have a fixed volume. They do not have a fixed shape. So water, Coke, tea, milk, there's no fixed shape to it. And they do change their shape to fit a container. So if you poured water into your bottle, based on the shape of your bottle, the water would change its shape to fit into that container or into that bottle. So well done if you can remember solids and liquids. And finally, we had gases as our final state of matter. Gases do not have a fixed shape. They have no fixed volume. There is no fixed amount of gas, and they fill all of an available space. So if there is a gas, it will fill all the space available to it. So well done if you were able to remember all three states of matter and their properties. Now, this was part of your do now, the process of changing from one state of matter to another. So we know if we had a solid, like ice, and it changed to a liquid, that would be known as melting. If we had a liquid, like water, and it changed to a gas, if you boiled the water and it changed to a gas, that would be evaporating. If we had a gas and it changed to a liquid, that's called condensation or condensing. And finally, can you fill in the last one for me? So I have a liquid like water and it changes to a solid like ice. What is that process known as? Yeah, well done. It's freezing. So if it's very, very cold, you might see puddles freeze, or you might see a lake freeze, or if you put some water in your freezer in little cubes, it would turn into ice cubes that you could then put in your drinks. So gas to liquid is condensing, liquid to solid is freezing. So well done on all your revision. It's great to see that you know so much based on last week's lesson. So now we're going to move on to this week's new learning. We're going to learn something a little bit different. There's lots of new terms, new vocabulary that we're going to have to practice and learn, but I'm sure you'll all be experts at it by the end of the lesson. So the first thing we're going to look at is dissolving, and that is going to be part of our experiment. We're going to look at dissolving different solids, as you can see from our WALT as well. That is the focus of the lesson. So dissolving is when you mix some solids with a liquid and they appear to disappear and can no longer be seen. So you put a solid into a liquid like water and then it appears to disappear. Now it is still there, but we cannot see it anymore. So that is when something dissolves. So an example of dissolving would be putting sugar into water and sugar dissolving in water. That is one example. Now when I put sugar in water, it has not disappeared. It just appears to have disappeared. It seems like it has disappeared, but it is still there. It has mixed with the water to make a transparent or a see-through liquid. So if I put my sugar into the water and mix it around, the water would be still transparent. It would be see-through, even though the sugar was still there. So it would have dissolved into the water. Now, how do you know it's there? Well, you'll know it's there because if we were to drink the liquid, it would taste very sweet as a result of the sugar being in it. So the water would taste different because you would put sugar into it and it would have that sweet taste from sugar. So that's how you know it is still there. It hasn't disappeared, it just seems like it's gone, but we still know it is there through taste and through science, of course. There's the further explanation. Because the sugar has fully mixed with the water and is no longer visible, it is classified as being soluble. That's one of our new words, soluble. Good. So soluble means that it was able to be dissolved. So the sugar is fully mixed with the water, it's no longer visible, you can't see it, so it is soluble. Now the opposite of soluble is insoluble. My turn, insoluble. If it had not mixed and was still visible, so if the sugar hadn't disappeared, it would be known as being insoluble because it had not dissolved. So soluble is when it dissolves, insoluble when it has not dissolved. And what dissolved means is when you cannot see it anymore when the solid has mixed with the liquid. So once more, my turn, soluble. Good. My turn, insoluble. Excellent. So they're the opposite of each other. Okay, another new word we have is solute. So you can see the solute here. Sugar is the solute. The solute is the substance or what you are going to be putting in to your water. It is the substance that has been dissolved by another substance. In the example we have looked at, the sugar is the solute. Right, my turn. Sugar is the solute. Your turn? Yes, sugar is the solute in this example. Therefore, the water would be the solvent. So you put the solute into the solvent to see if it dissolves. If it does dissolve, it's soluble. If it does not dissolve, what is it? Yes, insoluble. Good. So a solvent is the substance that dissolves another substance. In the example we've looked at, the water is the solvent. So we have sugar as the solute and water as the solvent. Okay, this is just a diagram explaining exactly what has happened in the example of our sugar and water. So we had a solute, which was sugar. We added it to a solvent, which was water. And we ended up with a solution, which was sugar water. So a solute plus a solvent gets you a solution. The solute was sugar, the solvent was water, the sugar plus water gave me sugar water. The solute plus the solvent gave me a solution. Now this diagram is really helpful and it's going to help you explain your experiment later on. So what I need you to do now is to pause the video, and I would like you to draw this diagram very quickly into your book to help you with the vocabulary and to help you with your experiment later on. So pause the video here and draw this diagram into your notebook or your copybook. Great. We are now going to move on to our experiment. So we've looked at all our keywords. We're going to quickly revise them in a moment. And we have our diagram ready to go to refer back to if we need to. Alright, so I'm just going to check your understanding of the different words we've covered so far. So, the first word we're going to revise is soluble. Now, what does soluble mean? Yes, soluble means that the solid was able to dissolve in the liquid. Excellent, well done. It was able to dissolve. Fantastic. Now the next word is the opposite of soluble. It's insoluble. What does insoluble mean? Yeah, absolutely. The solid was not able to dissolve. It did not disappear or did not become see-through. It clouded the water and it did not dissolve fully. Excellent. Next word, solution. What does solution mean? Yeah, absolutely, well done. Solution is what becomes of the liquid when you dissolve it. So our solution was the sugar water. The sugar plus the water created a solution. Well done. You've mixed the liquid and the solid and you've created a solution. You might have heard of eye contact lens solution. That is chemicals mixed together to create a cleaning product and to wash people's contact lenses. That is also a solution. And our last word we're going to have to check before we do our experiment is solvent. What does solvent mean? Yeah, definitely, well done. Solvent is the liquid that the solid has dissolved into. So in our little example earlier, the solvent was the water because that was the liquid. The solute was the sugar as the solid, and it created a solution. So very well done. If you're still a little bit unsure of what each word means, just rewind the video and go back to your diagram and have a quick little revision of that. Otherwise, we're going to move on to our experiment. So we're going to look at 3 different solids. We're going to investigate 3 different solids, whether they're soluble or insoluble. We're going to look at flour, we're going to look at sugar, and we're going to look at tea leaves. Now in a moment you're going to have to make a prediction whether the flour, the sugar, or the tea leaves will be soluble or insoluble. So here is my prediction sheet and my answer sheet. very easy today. We only need to write one word in each box. And I have attached this as a PDF as you're in your home learning, so you're absolutely welcome to print it out and stick it into your book and to post on Seesaw. Otherwise, you can very simply just draw out the grid. That is absolutely fine as well. There is no obligation to print, as I always say. You can just draw out the diagram quite simply with the names and your prediction and your result. Right, so the first thing we're going to have to do is make a prediction. Now, I will make a prediction too in a moment, but I would like you to make your prediction first. Based on what we know, and what you know about flour, sugar and tea leaves, do you think it will be soluble or insoluble? So I'm going to write my prediction. I'm going to say the flour will be insoluble. I don't think it will dissolve fully. I'm going to say the sugar will be soluble. And I'll say the tea leaves will be insoluble. We'll see if I'm right at the end. So you need to pause the video here and write in your predictions. They could be the same as mine if you agree with me, but you're welcome to disagree as well because this is only a prediction. So pause the video here and we'll see how we get on in a moment. Okay, right. I'm going to leave this for a moment and write my results in afterwards. I'm now going to set up for my experiment. You can just watch the experiment and then maybe do it later on, or if you want to pause the video in a moment after I explained it, then you can get your materials and join in with me. So, I have sugar, I have flour, and I have tea leaves. To get my tea leaves, I opened up a tea bag, I just ripped it and poured them into the container. Now, you may not have containers or cups the same size. Please don't worry. The reason I am doing this, I'm just lucky enough to be in school at the moment, so I was able to get 3 containers the same size to create as fair a test as possible. But please don't worry too much about that. If you can just follow along and do it in some capacity, that's absolutely fine. I've also aimed to put the same amount of flour, sugar and tea leaves in, so it's as fair a test as possible. I also have my water here, as you can just about see, and I'm going to have to pour my water in to each container and see if the water dissolves. I also have a spoon, so this is what you need. You need 3 cups with tea, sugar, water, a spoon and a jug of water to pour it in. Now if you don't have these at home, please don't worry, you can still complete the experiment alongside me by watching me. That is absolutely fine too. So the first one we're going to do is flour, as that was the first one on my sheet. So I'll just move the tea and sugar away, get my flour, and I'm going to pour some water in. We're going to have the same amount of water in each cup just to make it as fair a test as possible. So in it goes. Now you can see this is transparent, that's see-through water. Just need to look at the difference to make sure we know if it's soluble or insoluble. I'm going to give it a quick mix around. I'm not going to write my answer in yet because I'm going to give it a chance to see if it actually becomes soluble. At the moment it seems insoluble as it is quite muddy and cloudy, but I'm going to give it a chance. I'm going to put it to one side and then I'll write my answer in at the end. Alright, next up was sugar. So I have my sugar here in my cup, I have my water, and I have my spoon. Once again, I will pour in the same amount of water for the sugar, and I'll give it a mix around with my spoon. I'm making an absolute mess of my desk. Hopefully you'll be able to keep your own homes a small bit tidier than I'm keeping my desk. So I've mixed it around. Seems pretty soluble. looks like it's dissolved. I'll put it to one side with my flour, and finally I'll take up my tea leaves. Now my tea leaves are just a split tea bag. I'll pour my water in once again, the same amount. And I'll mix it around. Already it doesn't look like it's going to dissolve. It looks like it's going to be insoluble. I'll mix it around. I'll just put it to one side. Okay, I'm now going to bring back my 3 different solids that I put into liquid. So, that was my flour, that was my sugar, and that was my tea leaves. I'm going to get back my prediction sheet. Which is here. And based on what I've just seen, I think I can say with a fair amount of confidence that the flour was insoluble. So my prediction was correct. I could say the sugar was soluble. I'll just show it to you again. Yeah, it's see-through. I mean, I can see my words all the way through the sugar water. So it was soluble, I was correct. Now, Limerick, you know that Mr. Murphy is quite often incorrect in his predictions in science because experiments don't always go as planned, but so far he's doing quite well. And finally, there's my tea. That is definitely insoluble. I can't see through that at all. It's not transparent. Okay, so now when you go away and do your experiment, you can write in your answers. Or if you followed along with me instead and don't have the equipment at home, which is fine, you can just write in the results based on what I've done too. That is absolutely fine. Now before we go, I have 2 questions as a plenary or as a conclusion for you to think about, which we're going to discuss in our briefings in the afternoons. So if there is someone at home, or you can just debate this with yourself, I want you to think about why or how do you know that flour was insoluble? So think about the language we've just learned, the different terms, the different vocabulary, the scientific words we've used, and come up with an answer ready for your briefings. How do you know that flour was insoluble? That's one question. And I have a second one for you to really push you today. A discussion around tea. Now, the tea leaves I had to split out of a bag. So therefore, why do you think tea leaves have a bag around them? Why don't we make tea at home? Why don't your parents make tea? Why don't your teachers make tea by just pouring leaves into the cup? Why do they have to put a bag around them in the shops for us to make tea? There's 2 questions there around the flour and the tea. We discussed sugar earlier on. I hope you enjoyed the lesson, and I hope to see some evidence on Seesaw of your predictions and your results, and maybe some videos as well of you undertaking this experiment. So we'll talk about those 2 questions in the briefings, and I will see you very soon again for another science lesson. Have a lovely day. Bye.